Good morning, friends. Welcome back to the new lecture 28, which is discrete Fourier transform. Which is the formula of x of n, which is 1 by 2 pi, 2 pi to 0, e raised to j omega, which is e raised to j omega n. So x of e raised to j omega, which is which is 2 pi to 0, x of e raised to j omega, the 0 of j omega d omega. So x of u j omega, which is summation you are taking, is infinity to n equal minus infinity. X of n into e raised to j omega n. Is x of n, a of n, u of n, mod a, where it should be less than 1. X of e of j omega, which is summation of infinity n equal to minus infinity, x of n e raised to j minus j omega n, which is infinity to 0, a of n, a of n e raised to minus j omega n, which is a of n minus j omega n. This is 1 by 1 minus a of e raised to j omega. This is 1 by 1 minus a of cos omega. Cos omega minus j sin omega. So moving further, which is 1 by 1 minus a cos omega plus j a sin omega. So which is 1 by 1 minus a cos omega plus j a sin omega into, we are taking this coefficient on both sides and multiplying, we got 1 minus a cos omega minus j into a sin omega. 1 minus a cos omega square and a plus sin square omega. X of e of j omega q of u is equal to x of e of j omega x of u of j. This is 1 by root of 1 minus a cos omega square plus a sin square omega and tan inverse of a minus a sin omega 1 minus a sin omega. It is magnitude log of the given by pi to minus pi to plus pi. This is the rough of this diagram. And important things to notice, pi time shifting property we are using x of n into d of t, t5 Fourier transform is e of x of e of j omega and x of n is x of j omega into x of j omega we are taking, and x of n is equal to n into e raised to j omega. The plotting both side of x of 1, we are getting magnitude plot will be changing in the phase of 2. This is the magnitude plot diagram. X of we are taking both sides. Find the Fourier transform is the question, and x of n we are taking 1 by 2 pi pi to minus pi and 2 pi. We are writing here which is x of e of j omega into which is infinity to k minus infinity 2 pi f into you are taking it and considering the casual relativity system and find the Fourier series which is um, let us take dft of x of n which is e of j omega y of n is equal to y of e of j omega is the x of e of j omega and taking y of n time shifting property we are using which is e of j omega and y d of j omega. Just taking this like we are doing it shifting the time with respect to e of j omega. So first we are taking e of j omega and y of e of j omega, and here the same y of n is y of n minus 1 by 4 y of n minus 1 x of n e of j omega minus 1 by 4 e of minus j omega x of e of j omega x of e of j omega x of e of j omega x of j omega and with the 1 by 1 minus 1 by 1 minus 1 by 4 e of e raised to j omega x of n over to x of e of j omega. This is the further simplification. Further we are doing with this and this the system. We're taking this and you're taking this. By 1 minus 1 by 4 e of j into 3 pi by 4 e of e raised to minus j 3 pi by 4 by 2j. Make the operation function 1 by 4 1 by 1 minus 1 by 4. We're taking this and we're getting the value and further simplifying for this and this one. So it's B2 like comment share subscribe.